Hello everyone, welcome to Husky Math. Today we will discuss about properties of definite integral. So using some properties of definite integrals, we can solve the problems in much easier way. So there are 7 properties which we have to remember. Let's discuss one by one. Property number 1 says, if there is integration from a to b f of x dx, and this will be equal to the value if the variable is changing from x to t. So if we change the variable without changing the limits, the value of the integral does not change. Property number 2, if there is an integral from a to b f of x dx, and here if I switch the upper limit and lower limit, that means if I integrate from b to a f of dx, then this value will be negative of the original value. So here previously the lower limit was a and upper limit was b, and on switching the limits you will have to multiply the value with negative. So this is the second property which we have to remember. The third property is, if there is a integration from a to b f of x dx, now here, so if I assume a number line here, if this point is a and if this point is b, and we are integrating from a to b, and if there is any point c in between this a and b, then the value of the integral will be same as the sum of the integral value from a to c plus the integral value from c to b. That means this integral can be written as integration from a to c f of x dx plus and from c to b f of x dx. Here, but we have to note that this point c should lie between a and b. Property number 4, if there is an integration from a to b f of x dx, and this value will be equal to f of lower limit plus upper limit minus x dx. Property number 5, if integration from 0 to a, if you see that my lower limit is 0 here and upper limit is a, so this property number 5 will be applicable only if the lower limit is 0 and upper limit is non-zero. Now the value of this integration will be equal to integration from 0 to a f of a minus x dx. Actually this property is coming from property number 4 only, because in property number 4 we have to add lower limit and upper limit and subtract minus x. So here also we are adding 0 and a, which will give a and minus x dx. Property number 6, if my integration is from minus a to a, now here note the limits f of x dx. Now this integral can have two values. It can be either 0 or 2 times integration from 0 to a f of x dx. Now the value will be 0 if the function fx is odd, and this value will take this lower value if the function is even. Now we will be discussing what is an odd function and what is an even function while doing the exercises. But here in property number 6, you note that my limit is from minus a to a. And at last the property number 7, from 0 to 2a f of x dx. Now this will also have two values, either 0 or 2 times integration from 0 to a f of x dx. So this integral will be 0 if f of 2a minus x equals to minus f of x, and it will take the lower value if f of 2a minus x equals to f of x. So let us summarize all the 7 properties. So these are the 7 properties which we have discussed just now.
Question number 1. Evaluate integration from 0 to pi over 4 log of 1 plus tan x dx. So here in this question, we will be using this property, that is integration from 0 to a f of x can be replaced as a minus x. So using this property, but first let us consider the given integral as I. So let I equals to 0 to pi over 4 log of 1 plus tan x dx. So let this be equation 1. Now let us use the property, that is instead of x we have to write a minus x. So here the value of a is pi over 4. So instead of x we will be writing pi over 4 minus x. So using that property, this integral I will be equal to integration from 0 to pi over 4 log of 1 plus tan, instead of x we will write a minus x, that is pi by 4 minus x dx. So here we will open this tan pi by 4 minus x using the formula tan a minus b. So here I equals to integration from 0 to pi over 4 log of 1 plus tan of a minus b is tan a minus tan b whole divided by 1 plus tan a into tan b dx. So this implies I equals to integration from 0 to pi over 4 log of 1 plus tan pi by 4 is 1 minus tan x divided by 1 plus tan pi by 4 is 1. 1 into tan x is tan x dx. Now let us simplify the terms inside the curly bracket. So I equals to integration from 0 to pi over 4 log of, on simplifying here it will be the LCM of 1 plus tan x, and in numerator we will have 1 plus tan x plus 1 minus tan x dx. So here tan x and tan x got cancelled. So we will have I equals to integration from 0 to pi over 4 log of 2 by 1 plus tan x dx. And since we know the value of log of a minus b can be written as log of a minus log of b, so we will use that here, 0 to pi over 4. So here it will be log of a minus log of b, that is 1 plus tan x dx. So separating the integral, we will have I equals to integration from 0 to pi over 4 log of 2 dx minus integration from 0 to pi over 4 log of 1 plus tan x dx. Now if you notice, then from equation 1, this is our integral, that is this is the same as in question. So this we had considered as I from equation 1. So instead of that we will write I here. So this implies I equals to log of 2 is constant, log of 2 integration from 0 to pi over 4 dx minus this part is I. So bringing that minus I here, it will be I plus I equals to log of 2 integration of dx is x, and our limit is from 0 to pi by 4. It implies 2i equals to log of 2, and putting the upper limit we will have pi over 4 minus lower limit is 0. So this implies I equals to 1 by 2 log of 2 into pi over 4. So this equals to pi by 8 into log of 2. So this is the answer.
Question number 2. Integration from pi over 5 to 3 pi over 10 sin x over sin x plus cos x dx. So here we will be using this property where we have to change the variable x to a plus b minus x. So first of all, let us consider this given integral as I. So let I equals to integration from pi over 5 to 3 pi over 10 sin x over sin x plus cos x dx. So let this be equation 1. Now applying the given property, this can be written as integration from pi over 5 to 3 pi over 10 sine of, instead of x we will write a plus b minus x. So here we will write pi by 5 plus 3 pi by 10 minus x. We will write instead of x a, that is pi by 5, plus b, that is 3 pi by 10 minus x, whole divided by sine pi by 5, that is a plus b minus x, plus cos of a plus b minus x dx. So here let us solve this expression separately. Then this will be equal to, if I take the LCM on the first two terms, then it will be 10, and in numerator it will be 2 pi plus 3 pi, and writing minus x separately. So this will give 5 pi by 10 minus x, and cancelling 5 by 10 we will have pi by 2 minus x. That means the expression inside the bracket is pi by 2 minus x. Therefore I equals to integration from pi over 5 to 3 pi over 10 sine of, simplifying the expression we will have pi by 2 minus x whole divided by sine of pi by 2 minus x plus cos of pi by 2 minus x dx. So this implies I equals to pi over 5 to 3 pi over 10 sine 90 minus theta is cos theta whole divided by sine 90 minus x is cos x plus cos 90 minus x is sin x dx. So let this be equation 2. Now let us add equation 1 and 2, then we will have I plus I on the left hand side. Adding equation 1 and 2, we will have I plus I on the left hand side, and on the right hand side we will have integration of pi over 5 to 3 pi over 10 sin x by sin x plus cos x dx plus integration pi by 5 to 3 pi over 10 cos x by cos x plus sin x, can be written as sin x plus cos x dx. Now since the integral is of the same limits, so we can take out common the integration, then we will have I plus I is 2i equals to integration from pi by 5 to 3 pi over 10 sin x over sin x plus cos x plus cos x over sin x plus cos x dx. So this implies 2i equals to integration from pi by 5 to 3 pi over 10, and if I simplify this term between the curly bracket, then it will get 1 and dx will be there. So this equals to integration of dx is x, but my lower limit is pi over 5 and upper limit is 3 pi over 10. So putting the upper limit, we will have 3 pi over 10 and minus inserting the lower limit, we will have pi over 5. It equals to, the LCM is 10, and in numerator we will have 3 pi minus 2 pi, which will be equal to pi over 10. But this pi over 10 is the value of 2i, that is 2i equals to pi over 10, and this implies I equals to pi over 2 tens are 20. So the answer for this integral is pi over 20. Question number 3. Evaluate integration from minus pi over 2 to pi over 2 sin square x dx. So here, if you notice, then the integral is from minus a to a. So in this type of integral, the value of this integral will be either 0 or 2 times integration from 0 to a f of x dx. So this integral will be 0 if f of minus x equals to minus f of x. That means if the function fx is odd function, and it will be 2 times of integration from 0 to a f of x dx if f of minus x equals to f of x. That means the function is even function. So before evaluating this integral, let us check the given function is an even function or an odd function. So here, if you see that my function f of x is given as sin square x in the given integral. Now we will try to find the value of f of minus x. So the value of f of minus x will be equal to sin square of minus x, and this equals to sin of minus x whole square, and we know that sin of minus x is minus sin of x whole square, and minus square is plus, and sin x whole square is sin square x, and sin square x is nothing but f of x, the original function. That means f of minus x is equal to f of x. So this implies the given function f of x is an even function. Hence we have to follow the second type. Therefore my integral, that is I equals to integration, that is my quotient, minus pi by 2 to pi by 2 sin square of x dx will be equal to, following the property, we can write this as 2 times integration from 0 to pi over 2 f of x dx. That means sin square x dx. So this equals to, let us try to evaluate this function. Then here it will be sin square x can be written as, from multiple angles, 1 minus cos 2x by 2 dx. So it equals to 2 by 2 is constant, 0 to pi over 2, 1 minus cos of 2x dx equals to 2 by 2 is 1. Now integration of 1 dx is x minus integration of cos 2x is sin 2x by 2. So this is the integral, but since we have to put the limit, that is from 0 to pi over 2. So using the upper limit, we will have pi by 2 minus sin 2 pi by 2 whole divided by 2, that is, this is the upper limit, minus lower limit is 0 minus sin 2 into 0 by 2. So this equals to pi over 2 minus, here 2 and 2 will get cancelled, and we know that sin pi is 0, so it will be 0 by 2 minus 0 minus minus is plus, sin 2 into 0 is sin 0, which is 0 by 2, and 0 by 2 is again 0. So the final answer for this question will be pi by 2. Integration from minus 1 to 1 log of 2 minus x over 2 plus x dx. Again, this is in the form of integration from minus a to a. So either the answer will be 0 or 2 into integration from 0 to a f of x dx. Now this will depend on if the function is even or odd. So here the function fx is, here the given function f of x equals to log of 2 minus x by 2 plus x. So f of x equals to log of a by b is log of a minus log of b. Now we will try to find the value of f of minus x. So f of minus x will be log of 2 minus of x minus log of 2 plus minus of x. So instead of x we have to put minus x. So this implies f of minus x equals to log of 2 minus of minus x is 2 plus x minus log of 2 minus of x. So this implies f of x equals to, let us take out minus common from these two terms, then we will have minus, and inside bracket we will have log of 2 minus x minus log of 2 plus of x. And if you notice that this particular term, that is log of 2 minus x minus log of 2 plus x, is nothing but this is f of x. So this implies that f of x equals to minus of f of x. And using and seeing this, we can say that the given function fx is an odd function. And since the given function is odd, that is f of minus x is equal to and minus of f of x, then the given integral will be directly 0. Therefore I equals to integration of minus 1 to 1 log of 2 minus x by 2 plus x dx implies that this integral will be 0.
Question 5. Evaluate integration from 0 to 8 modulus of x minus 5 dx. Since this is a modulus function, first we will open this modulus function, that is modulus of x minus 5, into two parts. So this will be plus of x minus 5 if x minus 5 is greater than or equal to 0. That means the value of x should be greater than or equal to 5, and this modulus will be negative of x minus 5 if this x minus 5 is less than 0. That is, this will be 5 minus x if x is less than 5. Now since we have separated this modulus function into two parts and the breakpoint is 5 here, so the integral I, that is from 0 to 8 modulus of x minus 5 dx, can be evaluated as, now since we have to integrate from 0 to 8, so here if you see in a number line, so if this point is 0 and this point is 8, and since we have to integrate from 0 to 8, so here we will put our breakpoint, that is 5 in this case. So first we will integrate from 0 to 5, and after that we will integrate from 5 to 8, which we can do by this property here. But here we have to note that this point C should lie between A and B, and of course 5 will lie between 0 and 8. So this integral can be opened from 0 to 5 at first, but the function between 0 to 5 is 5 minus x here, because modulus of x minus 5 is 5 minus x when x is less than 5. So between 0 to 5, the function I'll be using is 5 minus x, dx, and after that I'll integrate from 5 to 8, and the modulus function between 5 to 8 is x minus 5, because between 5 to 8 the value of x is greater than or equal to 5. So here the function will be x minus 5 in this case dx. So this equals to integration of 5 is 5x, integration of x is x squared by 2, and our limit is from 0 to 5, plus integration of x is x squared by 2 minus integration of 5 is 5x, and the limit is from 5 to 8. So putting the upper limit, that is 5, so it will be 5 into 5, that is 25, minus 5 square is 25 by 2. So here I put the upper limit and we have to subtract and put the lower limit, that is 0. So here 5 into 0 is 0, minus 0 square by 2 is 0. So here I open the first term. Now the second term, that is from 5 to 8, putting the upper limit, that is 8, and 8 square is 64 by 2, minus 5 into 8 is 40. So this is my upper limit, minus putting the lower limit, we will have 25 by 2 minus 25. So let us simplify this. So here it will be 25 minus 25 by 2 plus 64 by 2 is 32, minus 40 minus 25 by 2 plus 25. So here it will be 25 plus 25 is 50, minus 40 is 10. So here first it will be 42, and minus 25 by 2 minus 25 by 2 will be minus 25 only, and if I subtract this I'll get 17. So the required answer is 17 here. Here comes to an end of this video, and so these were the some questions where we applied the properties of definite integrals, but there are much more questions available which you have to practice to master this topic. So till then, keep practicing. See you in the next video.